Some rotated solids have open space in them in the middle, and so to find their volumes we're going to use what are called washers. So what are washers? Well, washers, you can get them at the hardware store, and they're basically metal discs with holes in them. Okay, now here's how we get the volume of a washer. We're going to get the volume. Okay, let me draw the axis of rotation through here too. So there's your axis of rotation. All right, so we're going to get the volume of the whole thing and subtract out the volume of the hole. Notice that with this washer, the thickness is dx. Now, the volume of the whole thing, that we're going to get by using this radius here. Okay, I'm going to call that the outside radius, and then the volume of the hole is going to be calculated by using the inside radius. Okay, so the volume of a washer is pi times r out squared minus r in squared times the thickness. Okay, getting the volume using the outside radius would be, if it was solid, subtracting the inside radius takes out the area of the volume of the hole. So that's the basic concept. So let's look at this example here. So let's say we've got two functions, y equals the square root of x and y equals x squared. We're going to look at them from x equals 0 to 1. We're going to rotate it around the x-axis. And here I've graphed them in GeoGebra. The kind of light green one is the square root of x, and the blue one is x squared. We're going from 0 to 1. And watch what happens when I rotate these around the x-axis. There we go. Hang on a minute. We get this shape here. Okay? So you get kind of a horn looking thing, don't you? Can y'all see that? Let me rotate that around again here. Okay, rotating around the x-axis, it's going to look like this. And let's do that from a different angle. Here we go. Okay, so y'all can see that there are two functions and there's some empty space in there. All right. So I've drawn a rough sketch here, and let's draw our representative washer at a random point, x comma y. So there's this. And then here is the hole. Okay? So our outside radius is going all the way out to this function here, which is y equals the square root of x. And our inside function is going up to this right here, which is x squared. Okay, so the volume of a washer is pi outside squared minus inside squared times the thickness, which is dx. If we simplify that, that's pi x minus x to the fourth dx. We're going from 0 to 1. So the actual volume is pi times the integral from 0 to 1 of x minus x to the fourth dx. Okay, let's do this on our calculator. Math 9, 0 to 1 of x minus x raised to the fourth dx, and we get 0.3. So our answer is 0.3 pi cubed. cubic units. Alright, now we're going to add our final twist, and what would we do if we're rotating around a line that is not the x-axis or the y-axis? So here's an example of that. So we've got y equals x squared, and it's going to roughly look like this. And then we've got y equals 4x minus x squared, and it's going to look roughly like this. And we're going to rotate this around the line y equals 6 up above. What is this point right here? Well, that's the point where they're equal to each other, so let's solve for that. So I'm going to go x squared equals 4x minus x squared, 0 equals 4x minus 2x squared, 0 equals 2x minus x squared, which is x times 2 minus x. So this point down here is where x equals 0, and this point up here is x equals 2. So those are going to be our limits for our integral. And this thing is going to rotate around the line y equals 6. Alright, here's a visualization of what's happening. It's going up and behind that line. Now, if I rotate this around so you can see it, there's the hole. Do you see that? Oh, stop. Okay, let's take a look at it again. So now it's coming up around that line, y equals 6. Okay. Okay, so I've done a rough sketch of what this thing looks like with a cross section. And our washer is going to be going like this. Okay, there's the front edge of it. And here's the hole. Ooh, it's getting complicated, isn't it? Okay. Now, the key is to measure everything from the x-axis. So, this distance is up to the x squared. So I'm going to make that y1. I'm going to make that y2. So this is y1. This distance is y2. And this distance is 6. Okay. So, here's our outside radius. It's going from the axis of rotation down to y1. So our outside radius is 6 minus y1, which is 6 minus x squared. Our inside radius is going from the axis of rotation to y2. So that's going to be 6 minus y2, which is 6 minus 4x minus x squared, which is x squared minus 4x plus 6. Now we've got everything we need. So the volume of one washer is pi outside radius squared minus inside radius squared times dx. Oh, I hope you guys can see that. Hang on a minute. There, I've moved it over. Okay, so that means that the final volume is pi times the integral from 0 to 2. Remember, we figured out this point was at x equals 2, y equals 4. 0 to 2 of this whole thing right here. Okay, so you can see that I've put that into my calculator, just the way I wrote it. And let's see what the answer is. 21.33. Let's go to math frac. And that's 64 thirds. And don't forget that that is times pi.